Okay guys, so this is section 7.5. This is about graphing inequalities and systems of inequalities. So the graphing tool is going to be really important for this one in my math lab, and I know sometimes it can be a pain in the butt, so we're going to go through kind of how to work with that again. We're going to do two examples, I think. So this one is all linear. Both of these are going to make lines. So the way I like to do it is actually a little bit different than what you'll see in my math labs, like view an example. I like to leave it as an inequality and get y by itself. My math lab view an example switches everything to an equals, but I think it's just extra steps that you don't really need. You can do it either way. I prefer this way. So I'm going to take each of these and solve for y as my first step. When you divide or multiply by a negative number, you have to remember to flip your inequality sign. That's the only thing that you really have to remember that's different about inequalities. Negative 3 divided by negative 4 is positive 3/4. 12 divided by negative 4 is negative 3. So that's our first one. Then I'm going to do the same thing with the second one. So same steps, just getting y by itself, paying attention to when I divide by a negative. And I guess maybe that's why my math lab does it with an equals, so that you don't have to worry about it. But it's not a hard rule to remember, and it will save you time later. Okay, so I've divided by a negative, so my inequality sign flips directions because I divided by a negative number. Now, because I was able to follow through with the inequality the whole time, I can use the inequalities to decide on my shading. Okay, with graphing these, we're going to have to shade a certain direction. So when it is a greater than or equal to, we shade above the line. And when it's a less than or equal to, we shade below the line. Doing it the way my math lab has you do it, with just switching this to an equals, you can't really rely on that because you don't know whether or not it was supposed to flip, right? So if you do it the way my math lab does it, they have you use a test point on the graph to decide whether that's a solution or not, and that's fine. You can go through that method if you want. It's in the view and examples. Try their method if that's what you like. But this is how I do it. So as long as you followed your rules with solving the inequality, you can use these rules to determine your shading. Okay? So let's look at how to graph this. So we're doing a solid line first, because when it has that line underneath for the or equal to, that makes it a solid line on my graph. Solid line. I'm going to start at negative 3, clicking there, and then I've got a slope of 3/4, so that's up 3/4. Okay, so that's my first line. This one is going to be a dashed line because it doesn't have the or equal to. So I click my line tool again, but I switch it to a dashed line. Also starts at negative 3. But it goes up 3/2. Okay? Now, for my shading, it's this little paint can piece here. I'm shading above the solid line, but below the dashed line. So above the solid line would be this area here. This is all above the solid line. And below the dash line is this area here. All this is below the dash line. So the area that's shaded for both regions is this bit in here. The only part you want to highlight is the part that is shaded for both inequalities. And you hit save and check answer, and good job. Okay, so you only highlight the part that's shaded for both. So now I want to jump to question, I think it was 16. Yep. So this one is nonlinear. Okay, so these were lines, which made it a little more straightforward. So now we're going to do nonlinear. Sorry, this is going to take forever. Okay, sorry. So the first one, there's not anything really to solve with this one, but do you know what kind of graph this is? Well, if it has an x squared and a y squared, that makes it a circle. Okay, you need to be able to recognize that. So when we're shading less than for a circle, that means shade inside the circle. If it was greater than, we would shade outside the circle. Okay? This circle has a center at 0, 0, because it's just an x squared and a y squared, and has a radius of 2. Okay? If you don't see that from that equation, you need to go review circles, because that's on your final exam. So that's in 1.9 was circles. This second one, if I solve for y by adding the x squared over, so I'm going to add x squared to both sides, I should see that this is a parabola. X squared minus 1. So only the x is squared. So this is a parabola, and because of that minus 1, I can see that it's been shifted down 1. That's using my transformation rules. So this is a parabola. It opens up because this is positive here, and it has this minus 1, so that means it's shifted down 1. So all of that we're going to use when we're graphing. Let's do our circle first. It should be a solid line. Center is at 0, 0. Radius is 2. There's my circle. I'm shading inside the circle. My parabola has a dashed line because there's no or equal to, and it's been shifted down 1. So it looks like that. Then to determine where I'm shading, well, I'm shading inside the circle, less than the circle, but greater than the parabola, so above the parabola, which is on the inside. Above the parabola is in here. So if I'm above the parabola, but inside the circle, that means my answer is this area in the middle of it. So we hit save and check answer, and life is good. Alright, so these are pretty straightforward. They're going to use a lot of our old graphing rules and transformation rules, so it's good review for you to do these. You know, see how much you can remember without having to go back and look up your notes, because when you get to your final exam, you have to be able to do all this by yourself. So make sure you're practicing all those old rules and formulas. Okay? Alright, let me know if you have any questions.